Hello everyone, this is Brian Calc, and today we are going to be tackling the 2018 Aime Ii, number 11. So the problem goes, we are looking for permutations of the set 1, 2, 3, 4, 5, 6, such that the first element has an element greater than 1, so just the first element is not 1. The first two elements are not a permutation of 1, 2. The first three elements are not a permutation of 1, 2, 3, and so on and so forth. So I don't really want to count that. What I want to count instead is the complement. And I'm going to write that here so I remember to subtract from 720 at the end. So let's consider the first element. In the complement, the first element, we have it being 1, if we're only considering first element for now. And then we have 5 elements, and those can kind of do whatever. So for the next one, we have 2 elements. That's 1, 2, and 2, 1, but 1, 2 is already in this case, so we don't count it twice. So we just have 2, 1, and 4 blanks. For the next one, we don't want to count the ones starting with 1 or 2, 1, 3. So we have 2, 3, 1, blank, 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 3, 1, 2, blank, 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 and 2, 3, 1, blank, blank, blank. So that's 1, 2, and 3. But if you look closely, the number of cases is starting to rise already. I believe there's like 11 cases if we wrote out all 4. So let's try to be a little smarter than that, because I don't want to fill up my whole board with cases before I even start doing arithmetic. So if we're looking for a way to make the big cases smaller, let's start with the biggest one, 5. If we don't want the first, let's consider what happens if the first 5 are 1, 2, 3, 4, 5. Well, if those are stuck like that, then the last element has to be 6, like this. And here, if we have the first 4 elements or some permutation of 1, 2, 3, 4, the last 2 elements are 5, 6, or 6, 5. We already have 5, 6 here, so 6, 5. So here we have 1, 2, 3, 4, and 5. So we've covered all of our cases. But you have to be careful now, because these 2 cases on the bottom can overlap with 3 cases here. I'm going to call it 3 cases for the rest of the time being, because these kind of operate as the same case and we can just triple them. So let's get to some counting. 5 choices, that's 5 factorial is 120, 24, 3 times 6, 120 again, 24 again. And now the overlap. So if we have 1 overlapping with this one, that's 24. If we have 1 overlapping with this one, 3 open slots, that's a 6. This one, there's going to be 3 open slots, so 6. 2 open slots, 2. And for each of these 3, for this one it'll have 2 open slots, that's 3 times 2. And for this one it's 3 times 1, only 1 open slot. So, summing it up, 18 plus 24 is going to be 42, so that's 162 plus 144 gives us, I believe, 306, just to check really quick. 42, 66, 66 plus 240, yep. So for this one, we have 24 plus 6 is 30. Then we have 6 and 2 is 8, plus 6 is 14. 14 plus 3 is 17. 17 plus 30 is 47. And if we subtract that, we get 260 minus 1 is 259. And finally, we remember that it's a complement, so 720, that's the total number of cases, minus 259 gives us 461, which is indeed the right answer. So I hope you guys enjoyed the video. Like, comment, subscribe, all the stuff I'm supposed to say as a YouTuber, and I will see you all next time with the Olympiads. See you then. Bye.